Now, let's move on to potentiometer. Potentiometer is a displacement sensor that converts linear or angular motion into a change in resistance. For a simple potentiometric displacement sensor, the concept is based on the voltage divider. In this voltage divider equation, we can see that the voltage output is actually a ratio of resistance over resistance total and multiply it with voltage input. Applying the same concept, the potentiometer has a fixed resistance value which represents the total resistance. The movement of the wiper is depend on the movement of the motion arm which link to a probe. Thus, the position of the wiper determine the resistance value. The same equation can be simplified to measure displacement. Here we can see in this equation, the equation is directly related to the displacement ratio instead of resistance ratio to voltage output. This is because the displacement ratio is actually proportional to resistance ratio. Therefore, we can omit the resistance ratio and directly use the displacement ratio. There are two types of potentiometer, transitional and rotational potentiometer. Here it shows the resistance total is actually depend on the length of the resistive element. This is true in both transitional and rotational potentiometer. And this is the simple potentiometer where we can rotate the knob. There are 3 pins on this potentiometer. Pin 1 is the voltage input. Pin 3 is for ground. And pin 2 is where we read the voltage output depend on the position of the knob. The advantages of potentiometer is that it is cheap. We can get potentiometer in only few ringgits. Second, it is very easy to use. We just need to supply the voltage, then we will get the voltage output. The third one is adjustable. We can adjust the voltage depend on the voltage supply and potentiometer rating. Potentiometer rating is actually the maximum resistance in the potentiometer. Different potentiometer will have different potentiometer rating. However, the problem in potentiometer are, the first one is mechanical wear. The bearing in potentiometer can lose due to mechanical wear. It make the wiper cannot hold its position and slowly it will move back on its own because it cannot hold its position. This will cause the voltage output also slowly decrease. You may notice this problem in radio, where when you tune the radio's volume, but it slowly reduces the volume itself. This is caused due to the mechanical wear. Second problem is friction in wiper. The wiper can also wear due to friction, make it lose contact with the resistive element, and therefore the connection, the electrical connection is not firm anymore. For an audio device, this can be manifest as a crackle when we change the volume. Lastly is high electrical noise. Now, this is an example of sensor displacement calculation. The information given are the value of resistance is 100 kilo ohm and the maximum displacement is 2 cm. So, if the measured displacement is 1 cm, what is the output voltage for 9 volt power supply? This problem can be solved using displacement ratio and multiply it with voltage supply. So the equation is E voltage output equal to displacement ratio X over L multiplied with voltage supply. So it is 1.5 divided by 2 cm multiplied with 9 volt. 9 volt. Then it gives you 6.75 volt. So the voltage output at displacement 1.5 cm is 6.75 volts.